So these are some conversion factors between the metric system and what I call the American system. And I use these quite often as I'm teaching physics with the metric system, but students need to understand how that actually relates to their everyday life, because we are using the American system in the United States. And I use it too. You know, when I go to Home Depot or do something else, I'm not going to convert to the metric system and just use the American system, but I have the other one in the back of my mind. Now, some of these conversion factors that we find here are more common than others, and I'll try to point them out. In any case, any one of these here that I'm introducing or that you already might know will come in handy for the following problem that then I got directly from the book. So here we go. So kilometers to miles, divide by 1.6. There is really no quicker way here. Notice from meters to feet, multiply by 3. So 1 meter is about 3 feet. Yes, more accurately 3.28 or 3.3. But if I want to be really fast, 100 meters to feet, 300 feet. Did I say 100 meters to feet? Yep, I think I said that. From centimeters to inches, or the other way around, divide by 2.5 or multiply by 2.5. So for example, if I have 4 inches, that's 10 centimeters, or if I have 10 centimeters, that's 4 inches. Square kilometers to square miles, so that would be apply to 1.6 twice, which means, let's see if that actually shows here on my calculator, which means that you square it with itself, so 1.6 squared is that 2.56, which if I want to be fast, I round it to 2.5, just 2.5. But if I do it a little bit more accurately, so it's 1.609 actually, that I square it, you see that I come up with something really close to 2.59. That's where that is coming from. Now from meters to square feet, well, that would be square the 3, because again you have 2 dimensions. So 3 by 3 is 9, but notice it's a 3.28, so it's definitely going to be somewhat larger. In fact, a good one would be 10. So if I live in a house that has 100 square meters in Berlin, that's where I used to live, well, that would be 1,000 square feet. That was our apartment. The other way around, my house right now has 900 square feet, so I divide by 10, so that's 90 square meters if I want to talk to my parents. Let's see, square centimeters to square inches, again, square the 2.54. I have to laugh a little bit here because that I would really never do. I really have never had the use for that. The volumes here that we have would be, so cubic centimeters to cubic inch, and by the way, I don't know this top of my head. So what I would have to do here now is I would have to take the 2.54 that I had a moment ago and cube it. So there we go. I hope this shows. I think this shows. And enter, and 16.38. I rounded very generously to 20, right? But there it is, 16.38. But again, I would really never use this one here. This one here, by the way, from milliliters to fluid ounces, I have the back of my mind. It's a typical one, about 30. So you have, I have a can of soda here, which has 355 milliliters. Let's make it 360 divided by 30, about 12 fluid ounces. In fact, that's exactly what it says, 12 fluid ounces. All right, liters to cubic feet, I also would have to memorize it. I know it's somewhere around 30. Apparently, the more exact number is 35.4. Liters to gallons, I actually do have that pretty much memorized. I guess maybe I do it more often than not. 3.8 or rounded 4. Ooh, I have to fix a typo right there. As soon as I have the chance. Then kilograms to pound mass. Notice that the American unit for mass is actually the slug, but we don't use it in everyday life. We still use the pound. Technically, it should be the pound mass. So take the kilograms, divide by 2. So my weight or my mass is 200 kilograms. I divide by 2. I come up with, whoops. Now that one I really did wrong. My mass is 100 kilograms. So I multiply by 2, which is 200 pounds. Respectively, if I do it a little bit more accurately, I multiply by 2.2 and I come up with 220 pounds. And even though I'm sitting down, you'll probably see that, yeah, the guy is 220 pounds. Let's see, grams to ounces. I personally use that quite frequently. If I want to send a letter and I have in my mind grams and I have a gram scale, yeah, I kind of know that about 30, respectively, more accurately 28 0.35. Yeah, the 1 milligrams to ounces, I wouldn't do it, and here I have it. I think I'm trying to hold an ibuprofen into the camera here. Maybe you can see that. Don't do it from milligrams to ounces, because milligrams are used most likely for medicine anyway, and don't convert, because that could lead to a fatal prescription. Degrees Fahrenheit to degrees Celsius to degrees Fahrenheit, there are several conversions here. They are actually all the same, but depending on whatever you use it for. For weather, it's actually really simple. Multiply by 2, and at 30, it's an approximate value, but pretty darn close. So a tourist tells you, oh, you know, it's 30 degrees in Spain. That's where he comes from. And you say, okay, 30 times 2, that's 60. And then add the other 30 here, 90 degrees. Well, yeah, pretty warm in Spain, or pretty hot. And the other way around, a tourist comes here and says, okay, wow, this is really cool in Alaska here, kind of coldish in the summer, 60 degrees Fahrenheit. What does that mean? Well, you subtract 30, which is 30, divide by 2, which is 15 degrees Celsius, and there you go. All right, so these are the conversions from the metric system to the American system, which you really only need if you work in both systems. As I said, I teach physics. I like to tell my students, well, this is what these metric units mean. And of course, if someone was a tourist or working in another country. All right, I'm going to do the problems next, but I'm going to take a break here. All right, so just before recording, I had added from liters to gallons, and then in the meantime, yes, I did fix a typo right here. All right, so let's go ahead. These are problems from the book, and I hope that I'm going to keep it toward the top here so that I can have the screen where you can see me on the lower right. I hope I'm going to adhere to that. So let's get started. Which metric base unit would be used to measure the height of a door? Well, that would be the meter, which is, I have a meter stick right here, which is actually has centimeters, but the whole thing would be 1 meter. I don't know how far I have to move out that you can actually see that. All right, the metric base unit to measure your weight, well, it would be the kilogram, and then of course there is my statement about it, and I think it's in the book as well, mass versus weight. So kilogram is actually mass, but in everyday language, for example in Germany, we actually use it for weight as well, even though it should be the Newton. So in the American system, the pound is the one for weight, and as I said, we also use it, unfortunately, for mass, even though that should be the slug. All right, amount of soda in a bottle. By the way, I don't have soda with me, so I have milk here, which, by the way, yeah, actually it does say down here, liters. So 1.89 liters, that would be, it's not actually not the base unit, it's actually a derived unit, but all right. Weight of a book that you're mailing, so for example, this one here, which is called 100 Milliarden Sonnen, Geburt, Leben und Tod der Sterne, so 100 billion suns, birth, life, and death of stars, so a nice astronomy book. And that would be technically in grams, but they're asking for a base unit, so it's kilograms. Amount of gasoline needed to fill a car's tank, yeah, liters. If you go outside the United States, it will always be liters. Height of a computer desk that I'm sitting on, well, it looks like a few feet, so definitely meters. In fact, here's my meter stick, and then my desk is down here. You can hear me pound on it. Weight of a dog at a veterinarian's office, yeah, probably definitely kilograms, right? Grams would be, that would be a really light dog. What else do we have here? Dimensions of the newest HD TV. So the TV that I have in front of me, I would actually measure it in centimeters, but they're talking about the newest HD TV, so that could be actually a meter or meter and a half, possibly. Distance a student athlete ran on the treadmill during their latest workout, the base unit would be meters. If you're really running a lot on that, you could start measuring it in kilometers. Amount of water to add bleach for mopping floors, yeah, that would be in liters. And as I read through these here, maybe once in a while I skip one accidentally. All right, so these are the answers from the book. I hope, I believe I chose the correct answer already and then converted it to the American system with a couple of examples. So bedroom wall or any wall behind me, this is my office wall here, you know, it looks like maybe 15 feet across, 8 feet up. That's how I came up with those two numbers, 120 square feet. Divide by 10, 12 square meters. So that's the correct answer, respectively. I did it actually in reverse, so it's 12 square meters. Multiply by 10, that conversion factor that we had earlier. And yeah, this is 1 meter here, and there's approximately 3 feet in here. When you square it, that's 9. But again, you round up a little bit there, or round down, its conversion is actually 10. City Park ought to be 1,200 square meters. That's the most reasonable answer, which converts to 12,000 square feet. But 12,000 square feet is in a neighborhood of 100 times 120 feet, which really isn't that big. And my example here is 10 house floor plan, so that's not a big city park at all. So that's a little bit off there what they tried to do. Kitchen table, 2.5 square meters. So for example, the desk in front of me, so 5 by 5 feet, which indeed is 25 square feet. Kitchen floor, 16 square meters, 160 square feet, for example, 10 by 16 feet. National Park, the one that makes the most sense, is 1,000 square kilometers, which divide by the 2.5 from earlier, 400 square miles, and which is, for example, 20 by 20. Rocky Mountain National Park in Colorado is actually that big or that small. So those are really reasonable answers. Let's see, classroom table, 5 square meters. All right, the window that's behind me here, well, they put it in square centimeters. Maybe it's not big enough to put it in meters. It's approximately actually 1 square meter, and 1 square meter would be about 10,000 square centimeters because it's 100 times 100. And yeah, that's the reasonable answer that it gave us here. I don't know if I would want to convert it to square inches. Perhaps go to the store and say, I would like to have a window that's 30 by 50 inches. Paper napkin, by the way, I do have one right here. That would be measured in, apparently they say here, square millimeters, maybe square centimeters. You know, it's big enough. So 100 square centimeters, 10,000 square millimeters, 16 square inches, 4 by 4. Kind of looks like that, actually. Well, let's see, this one is 5 by 5, I think. Parking lot, 45,000 square meters would be the most reasonable answer. However, that's a huge parking lot because it converts to 450,000 square feet, which is 500 by 900, which is 6 football fields. Okay, so you have an arena for a sports event. I guess so. On the side around, they actually have an additional 6 football fields just for the parking. So that is a huge parking lot. All right, terrarium would be measured here in 50, or most reasonable answer is 50,000 cubic centimeters, which would be 10 by 10 by 30 inches when you convert that. You know, divide by roughly, what was it, roughly 20 and round up a little bit. Something I would really not do on a regular basis. Milk carton, I actually do have one here, except I have a big one. So actually, a milk carton would be more the size of this one here, or my coffee cup, which contains cold coffee right now. And that one actually would say 355 millimeters. It says 236 here. I guess a milk carton is a little smaller than a soda can. And that would be quite exactly 8 fluid ounces. That's actually what where the 236 comes from in the first place. So if you multiply, I believe the conversion was 29.57. When you multiply that by 8, you come up with pretty much 236. Box of crackers. I don't have a box of crackers here, but 1,500 cubic centimeters makes the most sense. Notice another little typo here, so I will fix that as well. Let's see, fish tank. I'm going to cough, which means I'm going to pause. All right, I'm back. So the fish tank here is most reasonable answer, apparently 71,000 cubic centimeters. The juice box, even smaller than my can here. Again, still, I don't have the juice box here. 125 milliliters. And a swimming pool, 45,000 liters. So if you convert that to cubic feet, I think there was a conversion of 30 or 40, so I'm dividing by 40 and round down, 10,000 cubic feet, because then I can fit these 3 numbers nicely in there, so that would be 50 by 20 by 10. I guess that makes sense for a good-sized swimming pool in the backyard, right? So 45,000 liters, yeah. Try to heat that. That's why we don't have swimming pools in Alaska, because that is a lot of water, a lot of heating that water. Even in the summer, I guess. let's see. So these here, aspirin tablet, 300 milligrams. I have an ibuprofen here. There it is. Well, don't convert to ounces. I mean, I could do it, but don't do it, because you want to have it accurately in milligrams, because you're more likely to come across milligrams when it is about prescriptions, and you want to have it accurately. Elephant, 5,000 kilograms, about 10,000 pound mass, and I looked it up. That is indeed correct for an Asian or African elephant. The baseball, I actually do have one here. There it is. You know, baseball is around 5 ounces, multiplied by roughly 30 ounces to, 30 grams to the ounce. So that's about 150 grams. That's what it says. 145 grams. Orange, I don't have an orange, but I guess maybe this is orange or red enough for an orange. So in the neighborhood as well, 115 grams here is the one that makes most sense. Pencil, when you look at a pencil, well, that's a fraction of an ounce, so 6 grams indeed is a fraction of an ounce, 1/4 ounce, right? Automobile, for an average sedan, I looked it up, 1,300 kilogram is the best answer, and it's actually pretty reasonable as well, the 2,600 pound mass that we see. Let's see, and the last few here, human body, 37 degrees Celsius. You would have to look at the formula. So for these kinds of temperatures, multiply by 2, add 30, or do it more accurately, multiply by 1.8 and add 32. Ice cube here, 0 degrees Celsius, you might know that, 32 Fahrenheit of course. Boiling water, 100 degrees Celsius, that's what the Celsius scale is based on, 212 Fahrenheit. And on a summer day, 23 degrees Celsius would be considered warm, which is then 76. So here we go, 23 times 2 is 46, plus 30 is 76. And on a winter day, it would be 3 degrees Celsius times 2, which is 6, plus 30, which is 36. By the way, if you do it with the more accurate conversions, you still come up with the number that's really close to the quick way. And when it comes to really large numbers, or in this case actually relatively large numbers, 700 degrees Celsius, just multiply by 2, forget about the 30, because 700 times 2 is 1400. If you add 30 or if you don't, it's still pretty darn hot, that lava, 1400 Fahrenheit. Alright, and with that, I'm done.